Hey everyone, welcome to Deploy a Game Server on Red Hat OpenShift. And yes, that was me. You just saw me on the screen right before we got started. My name is Bradston Henry, and I'll be your host for today, host for the evening, host for the morning, wherever you are across the world. Thank you so much for joining us. If you're watching us on Twitch, on YouTube, on Facebook, or even on Twitter, thank you so much for joining us today. It's going to be a great time, and I'm so happy to be here with you all. So once again, you are tuning into the Deploying a Game Server on Red Hat OpenShift. So if you haven't already, and you can see it in the chat, there is a link to the workshop materials, the webinar materials that you can check out in the chat, and that's at http://IBMBiz.biz djs-github-bradston dev. Please check out that link. That has all of the resources that you will need for today's webinar, for today's talk, everything that you will need to really participate and get the most out of the experience. So, without further ado, let's go ahead and get started. Before we get started, I do want to share some really important information. Jim, you mind sharing the first slide? That it is really important that if you're tuning in today, that you know that what we're doing is not just for game devs or game developers or indie game developers. It's for anybody who is a developer, anybody who's interested in web technology, in cloud technology, in, project management. If you manage teams and you just want to learn about, the technology that's out there and being used. A lot of what we're going to be covering today is things that is used in the industry at large, from companies like Slack and Zoom and different companies like that use a lot of the technology or similar technologies to really make their applications work. And I'll talk a little bit more about that as we get into this. But I wanted to make sure you knew that if you're here today, you are welcome and you're gonna have a great time and learn a lot, no matter where you're at. So let's go ahead and dig in a little bit deeper here. So what I want to do at the very beginning is show you guys what is going to be possible with the different code that I'll be sharing today, the different things that I'll be showing today, and what you're able to do with this code. So I'm going to show you guys a special experience. I'm going to flip over here to my desktop, and you guys are going to be able to see a game. Okay, so this game, we'll just call it the art show or the art room. And in here, you'll see that I'm walking around just walking around. So one of our colleagues, Kyle Smith, he's a developer. Not a developer, a visual designer, a UI designer, somebody who's done a lot of great work to help me to build this demo for you all. We'll be joining in here in a minute, and he'll actually be doing a live art exhibit of this environment. So it looks like Kyle hasn't joined yet, but what's going to happen is Kyle's going to jump in, and I'll pop in here a little bit later to show you guys a little bit of what he's up to. Oh, there's Kyle. Speak of the Kyle. Kyle, can you tell everybody hello? I'll give him a good squat there. Hey there, Kyle. So what Kyle's going to be doing is he's going to be painting. So if you want to go ahead and start painting, and what's going to happen is Kyle's going to be painting a portrait. And throughout the webinar, I'll be popping back in and sharing a little bit of what Kyle is doing. I'm going to go ahead and go to spectator mode so you guys can see what he's up to. But there's a reason behind this portrait and why it matters. So let's go ahead and pop back here really quickly back to our slides. And what will be happening is I want to talk a little bit about the art of the possible today. When we are going through this webinar, when we're going through everything that we're doing, I want you to know that everything that I'm showing you today, you can do something that you can contribute to a project that you're working on, something you can contribute to something, that you want to do for fun. But a lot of how we all got to the position we are today is because of other people's efforts, what other people have done for us and what other people have accomplished. And as Isaac Newton said, if I see so far, it's by standing on the shoulders of giants. And today I want to dedicate this webinar and what we'll be doing today to somebody who was a giant to me, who shared a lot and taught me a lot along the way. Somebody who a lot of you know just by watching this webinar today that you've probably seen this person in some capacity. Somebody who's made it so that I can make it this far, and somebody who's been inspiring generations for a long time. So let's continue on here and continue forward. Sorry, it looks like my mouse here has decided to disappear. Here we go. So let's go ahead and talk a little bit about me. So I'm going to share a slide, a little bit about me. I've been a developer about 7 years. My name is Braxton Henry. And if you're just tuning in on Facebook or Twitter or Twitch or YouTube, we're here. This is deploying a game server on Red Hat OpenShift. And I'm your host, Braxton Henry. As you can see here, I'm wearing literally the same shirt. But yeah, I've been a developer for about 7 years. I've done mobile development, web development, cloud development, and of course, game development, from what you can tell, from what you've seen on the screen on the other side. I'm also a huge gamer. I love podcasting, a former break dancer. I retired. Now it's just more break than dancing. And I love MMA, something that I've been investing in for a long while. So yeah, so that's a little bit about me, but let's talk a little bit about what we're going to be doing today. So just a quick breakdown of the agenda, what we'll be doing, what we'll be talking about. So today we're going to be looking at what is the basics of a client-server communication model. This is going to be really important for us as we're creating a multiplayer game server and give us the basics of all the things that we need to know. We'll also be talking about creating a multiplayer game node server, which you all are here for. And we'll be walking step by step on how to create it, going through the code. We'll be using Node.js and WebSocket to make that possible. Then we'll be looking a little bit at Red Hat, very quickly, the overview of what Red Hat is. And more importantly, how do we deploy our game server to Red Hat OpenShift? Because it's going to be something that anybody can do, anybody can use, and it's going to be really powerful. Just beyond, even if we're making a multiplayer game server, any type of server, the same things that I show you today will be applicable. And then finally, I'll show you a demo of how you can connect your game server with Red Hat OpenShift with an actual game application. So let's really briefly dig into the overall basics of what we'll be doing today. So the basics of a client-server communication model. So just to give you guys just a little bit of context, and oh yeah, as you'll see popping up on the screen, if you have any questions or comments, please throw them in the chat. I'd love to answer them, love to hear them. But yeah, the basics of a client-server communication. So essentially, what happens is you have what's called a client and a server. So just an explanation, a client being basically a web browser, a mobile phone, a video game, basically something that you as a user or a player or what have you would use to interact with an application. And then on the internet, out there somewhere in the cloud, on a server, a private server, a public cloud server, is what's called the server. And the server is what actually holds the data about the application and information that you need. So imagine you're going to log into your local bank's website and you want to check your account. Well, you'd go to your website on your browser, say Firefox, Chromecast, Chrome, or what have you, and you log in. What would happen is all of a sudden, a request would be sent to the server and the server would send you back some data. So that's kind of basic server to client communication. It's just you as the user uses some type of application and request information from a server. Now, how does that really apply to us? So today, what we'll be really working on is what's called a persistent connection between a client and a server. So what does that mean? So that means just like a phone call, you'll always have a persistent connection between you, the user using some application, and the server that holds some type of information. So a la, WhatsApp, a la Slack, a la Zoom, that's say video information or audio information. It's continually sending data back and forth. You're always seeing, even what we're doing right now would be a persistent connection. You're seeing me live on a camera, you're hearing my voice and it's coming through you in real time. The opposite side would be what you're kind of used to on a normal website, a non-persistent connection, which is you only connect with the server when you need information. And it's basically one request, one response. But what we'll be working on today is a persistent connection. So we'll continue back and forth and you'll continue to get information as long as you're connected to the server through your application. Now, when we're creating our multiplayer game server, essentially what's going to be happening is you'll see on the left side of our slide here, or our image, is our application itself, right? That'll be our client. That'll be us, in our case, using Unity 3D and our game application. And what will happen is we'll have actual network requests going through and connecting to our Red Hat OpenShift environment where our node server, which is running our game server, is hosted. And those communications will go into Red Hat OpenShift, go into our server, and they will actually use the method, a set of methods set up in the framework, which is called WebSocket, which is kind of a, I guess you could say, a commonly used protocol for persistent communication models and I guess you could say data passing. And it'll be using WebSocket to communicate with our server code. And that's just going to be our continuous conversation, right? Our phone call between our application and our server. So that's kind of the basics, right? I did a quick overview. As we go through, it'll make a little bit more sense. You'll kind of see it live. And as Kyle is working on the image, I'll flip over there right now. You'll get to see it on the desktop. You'll see that that's exactly what's happening right now. He is actually, I'm seeing live what he's doing. That communication is happening. So I'm seeing him paint this image in real time. All right. So let's go ahead and get started. We're going to go ahead and start jumping into the code and actually creating our server. OK, so if you haven't already, I really, really encourage you to go ahead and check out the workshop resources link that I've shared throughout the different chats. If you're on Facebook, Twitter, or Twitch or YouTube, you can check out the chat and you'll get that link. And if you're just joining, if you're just seeing what we're doing today, is we're deploying a game server on Red Hat OpenShift, and we're jumping into the coding of what it really takes to make it happen. And I am your guest, your host, not your guest, Braxton Henry, leading you through the way. So let's go ahead and jump into the actual code. So if you haven't already, go to the workshop link and you'll get a lot of the resources that you need to get started. Before we jump into the code, what I'd like everybody to do who's following along with me is to go ahead and get their Red Hat OpenShift environment started. So what you're going to want to do is navigate on the workshop page to the step that says get access to Red Hat OpenShift workshop cluster. And you want to go to the developer.ibm.com Open Labs link, and it'll open up a website that looks something like this. On here, on this page, what you're going to want to do is scroll on down, move on down to the bottom of the page where it says bring your own application. And what you're going to want to do here is click Launch Lab. What this will do is allow you to provision the lab. So something I want to note that's really important for anybody who's trying to follow along, if you go back to the workshop page, is to make sure that you go ahead and sign up for IBM Cloud. If you don't already have an IBM Cloud account, you're going to need it in order to get access to your workshop cluster. So if you could just click that link and you can simply log in. I'm already logged in, so I can't sign up, but it'll just take you to that. So you can see the link in the chat and go ahead and sign in. So just want to make sure you know that in order to follow through the steps, you need to have a login with IBM Cloud. So I'm going to go ahead and say launch Cloud, the lab. It's going to set up the lab really quickly, and I'm going to let that happen. And then we're going to come back to this later and use it as we go through the code and get ready to deploy. So this is just to get it going so that we can use it when we're ready. All right, so let's go ahead and get started with the code. So the first thing we're going to do is we're going to actually just open up a folder on our desktop or anywhere and get ready to set up a folder. So it might be a little bit hard to see, but I'm going to make a new folder and I'm going to call this multiplayer game server. Okay. And in this multiplayer game server is going to be where all of our code is going to be hosted. So what I'm going to do is I'm going to go ahead and open up a terminal window or a command line window on my machine. I'm going to go ahead and clean this terminal by pressing Command K or Control K. That's how you clean your terminal. And I'm going to go ahead and cd or change my directory into this folder. So a real easy way to do this, so you don't have to actually type in the actual path, is you can actually click and drag that folder onto your terminal. Let's go ahead and zoom in a little bit here so you guys can see a little bit better. Click and drag onto that terminal and press enter, and we are now in that directory. Now, once we're in that directory, we're going to use the command npm init. Now, for anybody who is following along and they want to really keep up with what I'm doing, I really encourage you, and I'm going to say this a lot throughout this webinar, to check out the workshop link and check out actually the blog version of this workshop. It's on IBM Developers. It's an article on IBM Developers blog, and it's called Deploy a Game Server on Red Hat OpenShift. Hey, the same name as this workshop. And this will actually walk you step by step through the process of what I'm going to do today. So if you're trying to follow along, you can use all of the different code that I have here on this page. Instead of having to type in, you can just go ahead and copy using IBM Developer's cool tool to be able to copy code. So I'm going to be flipping back and forth between this page and our terminal and our code window when we're going, to make it a little bit quicker, a little bit easier, and I'll be explaining the code as we go along. So as you can see here, our first thing we're going to do is we're going to initialize our project or our node server that will be running our game server. So we're going to type in here npm init. And what that does is starts a dialog to start creating a node project. Here, we'll see that since we're in this folder called multiplayer game server, it's going to ask us what's our package name. We're going to accept that. We're going to accept the version as 1.0. I'm not going to add description. But here at our entry point, just to let you know, to navigate through this, you're going to be pressing enter or return on your keyboard. At the entry point line, I'm going to type here server.js. This is really important. You could name it index.js. You could name it anything you'd want personally, server code.js, but I'm going to use server.js as my entry point for our server. So type in here server.js. I'm going to press enter. I'm going to press enter again because I'm just going to accept a lot of these defaults. I'm not going to worry about my author, at this point. And then once I'm finished, it's going to ask me, is that okay? And I'm going to press enter and say yes. Now, if we navigate back to our folder, multiplayer game server, you'll see we now have a package.json, meaning we've initialized our project. All right, now that we have a package.json, let's get into making our server code. So I'm going to go ahead and clean my terminal here by pressing Command or Control K. And in my terminal window, I'm going to type the words touch server.js. What touch does is actually create a file in the folder directory that you're in your terminal. So I'm going to press enter here, and I'm going to create the file server.js. Now, you don't have to use touch to create the server.js. You can do it through some other method, but this is my preferred method. It's a little bit quicker. So once we've created our server.js file, we're going to go ahead and open it. And I'm going to open it with Sublime Text here. In Sublime Text, I'm going to make sure I am well zoomed in. It's going to be where all our code is going to be housed, all of our server code for a multiplayer game. So let's go ahead and get started with our code. So I'm going to flip back over to the article. I'm going to scroll down, and we're going to look at our first set of code. So I'm going to go ahead and copy this. And once again, you can just click the copy button here on the article, and I'm going to paste it, and I'm going to explain a little bit of what's happening. So our first two lines of code, where you'll see his var UID equals ... and const WebSocket equals required ... This is actually us importing in some code or some frameworks that we're going to need for our project. Okay, so the first package we're going to need is Uuid Random, and you'll see here it's called Uuid Random. Uuid Random, all it does is it creates a randomly generated user ID. Later down the line, as we're creating our server and adding in players and users to our server, this is going to be really important because this is the way that we're going to be able to track users who are connected to our server. So we're going to need something like this. And to make sure that every user has a unique identifier instead of maybe me generating something. I mean, I could create my own code to do this, but hey, there's a package for it. Also, we're going to need WebSocket. I mentioned this a little bit earlier, but WebSocket is going to be the communication protocol or the communication framework that's going to actually allow us to communicate persistently or continuously across some type of connection, right? So that's from server to client. From client to server and back and forth. And it creates that telephone call, I guess you could say. So that's the two first introductory lines. But before we can continue, it's important that we actually add this code, these frameworks to our project. So what we're going to do is we're going to flip back to our terminal, and we're going to type in here npm install uuid-random and space ws. And what this does is installs these packages into our project so that we can use them when we're building and running our code. And as you'll see, there's a node modules file just appeared in our project folder, and that means that we have the files that we're ready to use, and everything looks like it went well. All right, so back to our code. Let me close this excess. There we go. Editor here. So now back to our code. So let's go back and jump back to our handy dandy article on IBM Developer. And I'm going to go ahead and copy over the next set of code that we need. and I'll walk you through what they are again. And once again, if you're just tuning in or if you're just checking out, we are watching, you're tuning into the live stream of the developing a game server on Red Hat OpenShift. Thank you to everybody who's listening on, watching and listening on Twitch, YouTube, Twitter, and Facebook. So I see Fool Snowbell asked a quick question here. So why var on UUID and const on the WebSocket thing? So honestly, that's just more of a, for me, that's just more of a stylistic thing. I could actually say const, but in this case, UUID, we're going to be using it as a, I guess you could say a function. And since we won't be modifying it, we won't be doing anything, so it doesn't need to be a variable. It can be a constant, but this is just more of a stylistic thing. There's no real particular reason. So yeah, this could be const, it could be var, but that's a great question. Thanks for asking, Fuel Snabel. Sorry if I'm pronouncing that wrong. I really appreciate that. Good question. So continuing further, I'm going to zoom out a little bit here so you guys can see a little bit more. So the next two few lines that we added are going to start setting up our server so that we can start getting ready to actually create the server, our WebSocket server. So you'll see here, we're going to make a const. And in this case, I'm making a const because, once again, stylistically, I'm not going to be modifying this variable. So I'm just going to keep it const. We're going to make a const called WSS, which stands for WebSocket server. And what we're going to do is we're going to use the function new WebSocket.WebSocket server. And what this does, it actually creates our WebSocket server. And it takes in different parameters or different configs for setting up our server. In our case, the only configuration or parameter that we're going to input in our this JSON object, you'll see these two squigglies, brackets, is port 8080. Now, I just want to stop and note why this is important, particularly because we're going to be deploying in Red Hat OpenShift. In Red Hat OpenShift, by default, it's going to be looking for our application to be exposed on port 8080. So we want to make sure that's port 8080. And as we'll see, we're not doing anything within the actual creation of the socket server other than saying, hey, the server started. This is just more for debugging. And so we know that everything's working. The next is we're just creating an object here called players data. Now, just a really quick note, all players data does is allows us to track our different players or to manage them when they're on our server. This is just going to be used for keeping unique information or unique data about each individual player. So if there's 5 players connected to our server, they'll all have they'll all be added to this JSON data or this object, and they'll have their own set of information. And this is what we're going to be using to pass to our other players to let them know about, other players being on the server. If you have any questions about that, please drop them in the chat. I'd love to hear them. So let's continue on. Now we're going to move on to adding what would be our WebSocket function. So once again, if you check out the article, you can just copy the code over, and I'm going to go paste it in here. So let's start from the top. So this is going to be our WebSocket functions. And once again, WebSocket is what's managing our connection between our client and our server. So the first line here is what's called the onConnection function. And essentially what this onConnection function does is actually manages the connection with our clients. So all of our other code that's going to be client specific, meaning sending data, receiving messages, hearing from messages, are all going to be contained within this onConnection function. You'll see here we have our connection, which is the name of our onConnection, which is a type of connection function, WebSocket function we're using. And we're going to have a function in here within it, a closure that actually manages our connection. So we're going to do most of our code inside of this onConnection function. Okay. Now, what's happening here? So when somebody connects, a client connects to our server, what happens is it initially fires this function, and we need to do some, I guess you could say, setting up of our client so that it can, communicate correctly with our server. So in this first line, you'll see where we're going to be using that UUID const, var, thank you, var that we made earlier to create our unique identifier for our client. So I'm actually going to attach this identifier to our client object, and that's the object that we'll be receiving through WebSocket, but we won't be using this much later, but just for now. So this is just creating a unique identifier for our client. I'm missing a line of code here. I'm going to grab it from the article, which is here. It's players data. I realized I made a minor mistake. I'm going to update the article earlier, but there should be a line right after this line that says players data that looks like this: players data and then client ID, so on and so forth. What this line does, it actually creates within our players data object I guess you could say an object that we can use to manage and track our player. So remember, we made this player data object that stores player data. This is just initializing this particular client, meaning the client that just connected, into our players data object, into our JSON object. And as you'll see here, I'm setting it based off of this client's ID that we just created. And then I'm using an object. I'm creating an object with one, I guess you could say, key that says position. And within this position object here, we'll have all of our data about our player. It's X, Y, Z, rotation, everything that we need to know out of our player. This is what's going to be updated pretty much live as we're connected to our players through the WebSocket server. Finally, I'm not using this variable in this particular context of the code that I'm sharing today, but this is just to show you that one thing you can do is you can create this thing called current client, which you could use within the WebSocket function for managing the client. We're not using this today particularly, but I like to show setup code. So in case you want to use it in the future. Once we've have everything set up, what we're going to do is we're going to actually send back to our client data about itself. So we're going to send basically its new identifier, or what the server identifies it as. What we're going to do is client.send. And basically what the send method does is exactly what it sounds like. It sends a message to our connected client. And we're going to send this JSON string that has an ID field and the string of the ID of the client. In this way, the client can identify themselves. So if I ever send a message to the client and I'm saying, hey, a client with ID X, Y, and Z, I want you to do this, it'll know that we're referring to that actual client. So that's kind of the basic setup for the initial connection of our client to our server. I see that I have a question here from Art Osegura. Is this what they teach at a coding camp? So I can't speak for every coding camp, but I can say that at coding camps, they can teach similar things, especially if it's a JavaScript based or Node.js based. They'll try to teach you different elements of code, and they might teach you about servers. They might teach you about front end, maybe React.js. They may teach you about Next.js, different things like that. So yes, stuff like this is taught at code boot camps, but I can't speak for everyone. But hopefully you can learn something today as we're going through this. And just, once again, for anybody who's just tuning in, watching on Twitch, Twitter, YouTube, or Facebook, this is developing a game server on Red Hat OpenShift. We're in the midst of building our server for our game server, the meat and potatoes of today, and I'm going through the code on how that works. All right, now we've set up the basic setup of our server, the basic handshake or connection between our client and our server. We gave our client an ID and we sent it to the client so they have it. Now it's time for us on our server to be able to set up these functions that manage, I guess you could say, the day-to-day or the second-to-second communication between our server and our client. So the first function we have here is our on message. So this is client.on and message. That's the on message function. And essentially what the on message function does is it receives messages from our client. So whenever our client initiates a send function, meaning, hey, I want to send information about my position or my rotation or something that I've done, it'll receive or catch that message within this function area here. Okay, we're going to fill this in a little bit more later, but right now it's just saying, hey, console log, we received a play message. The other method that we'll be using today is going to be the onClose method, or client.on and then the parameter of close. Essentially, all this does is listens for when a client disconnects from our server. So the client goes, hey, I'm closing my application. I no longer want to be a part of the server or this instance. Please close my connection. It goes ahead and close that connection. And this is where we do whatever kind of cleanup we need to do when a user disconnects from our server. All right, so last two bits of code code here. This is our our on listening function, WSS.onListening. This, I just want to note, is outside of our on connection function. This is outside, okay? And all this does is set up our server to listen on the port 8080, so it can actually do the communications between the client. So you need this for it to operate appropriately, but there's not much you need to do. You don't need to configure anything. And this is, once again, another debug within that function that once it starts working, we'll see listening on 8080. So we'll get to see that as we run our server. And finally, I just have a utility function here. And by utility, meaning a function that I can use multiple times for different use cases. All it does is remove an item once from an array. This is just so I don't have to think about it. You can check out this code. This is kind of common approach of how you would remove an item from an array by its indexed or by its value in an array. So you can check that out. All right, cool. Now that we set up the basics of our WebSocket functions, it's time for us to add some code into our on message function so that we can receive messages appropriately. I'm going to sound like a broken record, but this is where you flip back over to the handy dandy IBMDeveloper.com, developer.ibm.com, and check out the article so you can get the code for this section. So we're going to slide on down here to the section that says data transfer between client and server. And we're going to go ahead and copy this code. This is a little chunk of code, and we're about to go through it. So I'm going to click copied. And what I'm going to do is I'm just going to highlight all of this, and I'm going to paste it. Okay, I lost a little bit of my tabbing. That's okay. Don't worry about it. It's a little messy, but that's okay. Let's do this just for my readability. Okay, cool. So let's talk about what we want to do within our oops. I think I lost myself here. Let me reset. Yeah, there we go. I think I didn't actually copy. Let's try this again. There we go. Then I copied. I was like, what? Things look a little weird. Let's paste that there. There we go. That looks better. All right. So we're going to start from the top of our function, our on message function, and we're going to break down. I'm just fixing the tabbing so you guys can read it a little bit clearer. Okay. So let's start with our first line of code within our on message function. So the first is we're taking in some type of data. So I mentioned this a little bit earlier, but when our client sends a message, it actually sends us a chunk of data, and that data comes in as a JSON string. So it's just a string, value, and it allows you to then parse it, meaning turn it into a JSON object, so we can use it a little bit easier, and more readily on our server. So here, var data JSON, JSON.parse data. What we're doing is turning it into a JSON object. Now I'm going to briefly talk about what I'm doing here, but essentially to kind of make things a little bit easier for myself, because I'm not 100% sure what data my server is going to send. It could send us position data. It could send us message data. What I'm doing is I'm checking what kind of data was sent to me by checking the keys. So what I'm getting is all the keys within this JSON object, object.keys for my data JSON. And I'm going to be using that to actually check what kind of data, and also to populate our player's data JSON appropriately. So what you'll see is I'm doing a for each loop. And what it does is it takes each key from data keys, meaning each of the keys that we grab from our JSON object, from our message, and I'm going to assign it to our player's data object with the client's ID, which is retrieved from the data JSON. Because for me, every time that I send a message, I always send what the ID of the client is. And remember, I set up the object earlier with this position that was empty. We're going to go ahead and fill that position object with all the data by key. So it's kind of set up appropriately so we can access it, so we can use it, and makes it a lot easier. This is a really important, great function because it means that you can change your code on your client side and you don't need to worry about your server, because your server doesn't need to know all the keys. Otherwise, you'd have to do it manually and have to update your server every time. All right, here we just log out our position because that's, the data that was just sent to us. It just tells us, what the client sent. Here, I'll just kind of briefly mention what I'm doing is I'm making a temp data object so that I can modify it, because what I want to do is I want to send back to our client a slightly different object than what I have on my server. And if I don't do this, I'll actually be modifying the data on our server. Basically, this goes back to, I'm not going to get deep into this, but basically like reference value versus basically we're changing we're making sure that we're not changing the data in memory on our server. We're just getting a copy of that data. And because it's a JSON object, you're going to have to copy it using this method. So we're copying it. We're making a temp player's data. I'm getting all the keys. I don't want to send the type to the, which is, if you look at our data here, type player's data. I don't want to send that type in this. That's just how my client is handling it. So I'm removing that. That's what that remove item wants. And then I'm adding all of the keys to what's called players IDs. So what is happening here is that when I send my data back to my client, I'm actually putting in an array all of the different players that are currently connected to the server. This is a really quick way to do this. And it means that when my client receives all of my data from my server, it doesn't have to do a lot of work to figure out how many clients are there, what's their IDs. It already has it in an easily accessible way. So once I've done some modification to this temp player's data, what I do here is I send that data back to our client. So why am I doing this? So what's happening is our client sends us a message. I do a lot of different data things. I change things. I add things to the server. And then I send that data that I just modified on our server back to the client. What this basically creates is this continuous kind of communication model, right? The client sends me a message. I send the message back to the client. The client sends me a message. I send the message back to the client. And it kind of makes sure that at all times, the client is getting the most up-to-date data it possibly can whenever it sends information, right? So I know that, hey, if it sent me something, it's connected. So let me send it back. So it always is getting information about all the other players that are happening. I have a quick question here. I'm not going to spend too much time answering, but I see from Gaurav, he says he's trying to pursue a coding and learning technology, and he wants to make a career in coding. I would simply say, hey, I encourage you to check out developer.ibm.com. There's a lot of resources to learn about a lot of different subjects. I encourage you to check out the different things that we're doing here at IBM, as we do a lot of free education, a lot of free teaching, so you can learn a lot of things. And there's a lot of resources on the internet, different YouTube channels where you can learn. I just encourage you to full force, just kind of go after it. Actually, you might, I didn't say this in my intro, but I'm a self-taught programmer. I didn't go to school for programming. So, hey. So we've made our on message function. And once again, this is about receiving a message from our client, and then we're going to send a message back to our client with updated data that they can use for the game. Okay. So now we're just heading toward the ending of creating our server. We're going to do the last most important thing, is closing a connection on our server, removing a disconnected client. So I'm going to go ahead and copy this code. It's copied. You can see it's highlighted here. And what I'm going to do in our on close function, it looks like I deleted it. That's okay. I might need to just, there's going to be some errors in my code because I deleted some code earlier. But at the end of the article, I actually have the full code. So I'm going to go ahead and copy that and paste it at the end so we can run it, because I deleted some necessary code. But we'll just follow through and just look through this code. All right, let's talk about the onClose function. So as I mentioned earlier, the onClose function just manages client disconnections. So we just, and within this method, you'll see like console log, this connection is closed. So it lets us know that somebody disconnected and that we're going to be removing a client at this. This, once again, is for debugging, for checking our server to make sure things are working. Really, I don't have to spend too much time on this code, but I encourage you to check it out and see how it's working. But essentially what happens here is I use the WebSocket itself, and that WSS is what we created at the very beginning, that const, where we made our WebSocket server. WebSocket server manages by default all the clients that are connected in this property that called .clients. So I'm going into my clients, and for each of my clients, I'm sending them a message letting them know that another client has disconnected. So if there's player A, B, C, D, E, and F, and player B disconnects, I'm sending to all the other players, hey, player B just disconnected. You should do something about that. And within our client code, they would remove the player appropriately, clean them up appropriately. So that's what this for each loop does. Okay, so check that out. At the article, you can get a little bit more of an in-depth look. And finally, what I do is I remove that disconnected player from our player data object. This is really important because we don't want to have loose players just sitting on our server, just to ID the things that are happening. We really want to make sure that we're getting rid of them if they're not connected, or we're doing something with them so that our server doesn't get bloated as players connect, disconnect, and so on and so forth. Okay, so that's pretty straightforward. It's pretty simple. Client on close. It disconnects a player. It lets all the other clients know, hey, a player disconnected, and then it deletes that player from our server. Okay, so with that, we've literally, all this code has created a multiplayer game server. So what I'm going to do, because I deleted some code a little bit earlier, is I'm going to scroll down here in our article. You see where it says, here's the code for the completed multiplayer game server. And I'm going to go ahead and I'm going to copy all that. And I'm going to Control A or Command A and select all my code. And I'm going to paste it in so that, because I know that that code is correct. And as you can see, all our code is here. So I'm going to go ahead and save it. Now that our code is finished, it's time to run our server to make sure that it's working. So just for anybody who's tuning in, once again, you're watching deploying a game server on Red Hat OpenShift. My name is Bradston Henry, your host. You can follow me on Twitter at BradstonDev. And we are just going through the code. We're kind of finishing up the code for our server, and we're about to run and test it. So we're in our server, in our terminal, and the easy way to run our server and test that it's working is to write node server, and this is in our terminal window, .js. Once again, this is the node command, and this is server.js, and I'm gonna press enter. And just like that, we see server started, listening on 8080. That means we have no code errors and things like that. Right now, we're not gonna connect here. We're gonna actually, when we deploy our server out into Red Hat OpenShift, we're gonna do the connections, and you can see that happening. So I'll show that here in a second. All right, so I'm gonna go ahead and close this. And hey, everybody who's listening, hey there, Kushagra. Hey, happy to have you. Nice to see you. So, okay, let's go ahead and get to the next part of our webinar here, which is going to be, let's check out what Kyle has been up to. He has been painting a picture. He is almost done. He has a few more pixels left. We're going to check this out later, and I'll explain what that picture is and who that is and why they're important. But let's go ahead and deploy our server to Red Hat OpenShift. So if you haven't already, make sure that you have an Open Labs, that you've already created your Open Labs server. So once again, I showed that a little bit earlier. You go here and you launch the lab, and it'll create the server for you. Once you've created that server, let me just go ahead and close this. I'm going to click Launch Lab, bring your own application here on the Open Labs page. It'll take me to the course content, which will have my environment. If you click this hamburger menu in the top left, you'll see that we're there. I'm going to actually need to zoom it out a little bit because I need to switch. There we go. I actually need to switch here to the quick links and common commands. And on that tab, you'll see that it has a link to our OpenShift cluster. Okay, I'm going to go ahead and click on that. And it's going to open up my OpenShift cluster within my IBM Cloud account. So once again, you'd go on the main page of IBM Open Labs. You would launch, bring your own application. It would come to this page. It would open. And then you click the quick links and common commands on the left side tab under overview, and then select the access summary page link. All right. So once it's finished loaded, you'll see that your cluster has been created. It'll give you default names, probably starting with DTE, and show you that everything is great. Your cluster is working great. So what we're going to do is going to click Open WebShift Console, OpenShift Web Console to open our web console so that we can actually view our environment. Okay. So one thing I'll note, if you haven't already, make sure you check out the resources page, because we're going to be using the resources page, the web workshop resources page. It has the code that we just worked on, and we're going to be deploying it to our Red Hat OpenShift cluster. And we'll come back here in a second, but I just want to make sure, if you haven't already, that you've gone to that page. All right. So once we've opened up our web console, we'll be shown this page, and we'll be by default brought to our administrator page. I'm not going to be covering the administrator page today, just a deploying page, how to deploy. So what we're going to do, and then the left side of our screen, so we're going to click developer. From there, I'm just going to click skip tour because you don't need a tour. And what we're going to do here is we're going to click this button that says create project. Let me zoom in a little bit so you can see a little bit better. We're going to click this button that says create project. You can also create a project by pressing this little down arrow, the caret here, and pressing create project. And we're going to just call this multiplayer game server. I can't spell, so I'm just going to say mult game server. All right. You don't have to have a display name. I'm just going to say our server and some info in description. All this is optional. OK, once we do that, we're going to go ahead and click create. Now, one thing I want to note, as we're doing this, let's jump back over to our slides, because I want to talk really briefly about what Red Hat OpenShift is, because if you're watching, you're like, what just happened? We're joining on Red Hat OpenShift. Really quickly, Red Hat OpenShift is basically a containerization orchestration platform. And basically what it allows is for you to deploy applications in an environment that's pre-configured for containerized applications. And it allows you to check, to deploy your application using continuous integration, continuous development pipelines. It allows you to monitor your application, it allows you to check the logging, it allows you to set up auto scaling. It has so many great features. I'm not going to cover everything on this slide. I encourage you to check out the slides on the workshop resources page, but essentially it has a lot of features like a unified UI. So anybody who uses Red Hat OpenShift knows what's going on. And it also allows for hybrid multi-cloud solutions, meaning you can have your Red Hat OpenShift in different clouds like Azure, IBM Cloud, AWS. It's a great solution for deploying application, particularly containerized applications, meaning, hey, we made this application work on our machine and we were able to containerize it. We know it'll work in Red Hat OpenShift when we publish it. So once again, Red Hat OpenShift gives you all the power you need to deploy your applications, also monitor them, and allow you to scale them easily in one easy to use place. Okay. So let's go back to our Red Hat OpenShift web console. So on our console, once we've created our project, what we're going to do is we're going to actually create our application. So what we're going to do here is we're going to scroll on down to this option that says from Git. Hey there, Luke. Thank you for joining the stream. Yes, there's a little bit of art aspect, Thank you once again to Kyle Smith. He's the true artist. Anything that looks good today is because of Kyle, not because of me. I'm just a programmer. But once we click from Git, we're going to go ahead. In our first box, it's going to ask us for our Git repo URL. So it's really important if you want to deploy to Red Hat OpenShift that you have your code somewhere out there on the internet, on the interwebs. There's a lot of different ways, but today we're going to talk about Git. So if you're using our workshop link, hint, hint, use the workshop link, we're going to go ahead and grab the link for our repo from the link, because that's the correct repo. You'll see that it's going to validate it. It's going to look great, but it's going to say, hey, what's going on? Something's wrong. But what the problem is that we need to give it a context directory. So within my particular project, I have my server code within the server folder. So what we're going to do is I'm just going to copy server, because that's the name within our Git repo. So let's go back. Sorry. And I'm going to type in here server. So it looks like it's not doing it, but 99% of the time, once you have your code set up correctly, it'll automatically determine what kind of code you're using. So in our case, we're using Node. So normally it would automatically show you Node.js. This is honestly, I've done this probably 100 times, and 99% of the time, meaning this is the 1%, it automatically chooses Node.js for us. So it normally automatically chooses it, but I know that's going to be fine. It should be good. We're going to scroll down and it's going to ask us about our builder image. We can choose the default because Node.js 12 works perfect for us. And we can name our application. I'm just going to call it game server-app. And then I'm just going to say game server. All right. If I can spell, I cannot spell. Important thing, make sure these are all lowercase. Scroll down a little bit forward. Make sure under resources, it says deployment. And under advanced options, it says create a route to our application. This is important because we want a public URL for our application, our game to connect to. If you don't do that, it won't be public. It won't be able to connect. So let's go ahead and click create. So once you click create, it'll pop you over to what's called the topology view, where you can actually see your code. So I'm going to zoom out a little bit because it's going to be hard to see. You'll see that we've created a little pod with our code, and our code is actively building. I'm going to go ahead and click View Logs, and I'm going to switch over to our next part of our what we're doing as this is happening, because what's happening is this basically building our container image. It's putting everything together, and it's going to soon deploy our code out into Red Hat OpenShift. While that's happening, let's go ahead and set up our client to be able to connect to our server. So this is going to be really quick. I'm not going to really show too much of how this works. If let's fly back to our slides really quickly. I'm just going to show this for those who would like to go back and review this later. But I have a little bit of a slide on how this connection works. Essentially, Unity 3D is going to have some functions in it, and it's going to communicate with our server using WebSocket. I'm not going to go into the details because today that's not what our webinar or workshop is about. But you can check this out, and when you look at the code, which is, guess what, within our within the GitHub repo, you can check that out. So let's go back to our desktop here. So what I'm going to do is I'm going to open up a Unity project, and I have some default code with everything set up. If you don't mind, Jim, switching back to the desktop view. So yeah, thank you, sir. Thank you, Jim. And what we're going to do is I'm going to open a project. It's a blank project, and it's just called Create a Game Server for today. Okay, it's going to take a few seconds. But essentially what's going to happen is when we open up this project, when I'm going to show you where you can get the code, the package that I'm going to be using to make this happen. Within our webinar resources, within the client folder, you'll see this basics multiplayer scene package.unity package. This is just a package with all the default things that we'll need to make our client. So I'm going to make this big here, and I'm going to go ahead and open the package, and you'll see when I open the package that it will let me make sure I get the package. Well, I guess I'm going to need to download it because I can't find it on my machine now. So let me go back. Let me just go here, and I'm going to download it really quickly. I'm going to save it. I'm just going to open it. So when I open it, when we go back to Unity, one second here, you'll see that it's going to try to import in our package. One second. Sorry, I couldn't find it on my local machine. Let's try this again. The import is somewhere. Let's try this again. There we go. Sorry, it was taking its time. So you'll see that's going to import this Unity package. It has some scripts and has all the stuff that we'll need to make this work. So I'm going to go ahead and click import. And we're going to get some default information, particularly a scene that's going to allow us to test out our server. OK, so let that load here. While it's loading, let's check to see if our WebSocket server is working. It looks like that it has pushed successfully here. I don't know if you can see that. I'm going to go back to our topology page here. I'm going to click on our game server, and I'm going to go over to where it says pods under here. And I'm going to go over to the right where it says view logs. And you'll see that now I can see that my server has started and it's listening on 8080. OK. All right, so let's go back to our Unity code here. It looks like Kyle is finished, so we'll talk about that in a little bit here. But we're going to go to scenes in our folder. What's Kyle doing? Yeah, so Kyle basically has made our image. He's gone through and he's created our image in our multiplayer game. I'm going to talk a little bit more with Kyle. I'm going to pop in with him and show you guys a little bit of that. But while we're before we do that, I'm going to show you how to connect the server we just made to a multiplayer game. So once you've imported all the assets, if you go to the scene folder within Unity and open up the multiplayer scene, once again, if you're not a Unity person, that's OK. This could actually apply to any client. That could be a web browser. That could be a mobile device. As long as it has WebSocket and can communicate with your server, you're good to go. So in our scene, you'll see here, if I press the play button to play the game, all it does is, it's loading here, is I can move around this little cube in my environment. But we're going to do it with multiple people. So what I'm going to do is I'm going to go to my scripts file. I'm going to open up multiplayer, and I'm going to open up this file called Socket Manager. I'm going to say reveal in Finder. I'm going to pull that over here, and I'm going to open up this file with Sublime, and I'm going to change one parameter in our code, which is this socket. I'm going to uncomment it here so you can see it, but I'm going to put in the actual URL to the server we just made. OK, so let's go back to our server. I'm going to go back to topology view, select on our pod, and I'm going to scroll down to the bottom where it says routes. Routes actually shows you the actual published route or the URL of our server online. So if I were to click this here, it would take us to basically a blank page, but it says upgrade required. That's because it's a WebSocket and not an HTTPS page. So I'm going to copy that link. I just did that really quickly. And I'm going to go back to our code here, and I'm going to paste it here for this socket, new WebSocket. Okay. So y'all going to see, I'm doing this live. So wish me luck. I'm going to go ahead and remove this HTTP. Important thing to think, it needs to be WS:// for our server because we're connecting to the WebSocket through the WebSocket protocol, not the HTTP or HTTPS. Okay. So once that's saved, we're good to go. So how do we know it's working? I'm going to go ahead and close this. I'm going to go back to our Unity, and I'm going to press play. All right. When I press play, it's going to seem normal, but I'll show you that it's working here in a second. Oh, everything seems normal, but you'll see here that we got a little comment that says ID received. It might be hard to see on the stream, but I can prove it even more by going back to our Red Hat OpenShift, checking out view logs, and you'll see that it's receiving data, X position, Y position, rotation, and different things. This is the same server, exact same server we created today. It's receiving data. All right, but how can we prove that it's actually working? All right, one last step, and we'll be done today. We'll be coming in for a landing. I'm going to go ahead and build this application in my folder. I'm going to build it really quick. It'll take about 10 seconds because it's a really simple file. I'm just going to call it multiplayer game. You guys can't see this. Let me pull this over to the screen. I'm calling it multiplayer game. I'm going to save if my mouse will click save. There we go. So saving. And basically what it's doing is creating a build, an actual application build. And the reason I'm doing this is because I can mimic a multiplayer game session because I can play within the editor, which is the Unity editor, and I can also play from an actual build created by Unity. Okay. So I'm going to go ahead and pull this over here. So you see this, I'm going to press multiplayer game, and it's going to open an instance of our game in a small window. So you'll see in this window, there's a little blue square. I'm going to press play here in our Unity editor. It is playing. And when we pop into the game, we'll see two people. Now, how can I prove that this is two people? Let me go back to the game. And as I move here, my blue square in the small right screen, you see that it's moving on the left screen. And it is actually happening, real multiplayer. This is happening on our actual server in Red Hat OpenShift, and it is working. And that was all from the code we did today. Everything you can do this exact same thing using the links that I've shared on our workshop resource page. So that's it for today, really. But before we end and go in for our landing, let's stop back and talk with Kyle. Well, he can't talk to us technically, but he can communicate with us. So there's an image. Kyle made an image. So what is this image? So I mentioned at the very beginning of this webinar that somebody had inspired me to be great, to be who I am. And that person is a person who's very special to me, and I think is very special to the world. And let me show you a real image of that person. It's going to open up here, pull it over. This person. Now, who is this person? This person happens to be my dear old dad, Papa Henry, or Father Number One, as I call him. That's my dad. And actually, and I'll open this picture. This is a picture from when I was wee Mr. Henry. This is him. This is in the 80s. Like, yeah, I was a cool guy, even back then with my polka dot shirt and my dad with his cool suit. That's my goals, life goals, to be like my dad. But I'm going to switch back and forth. See, this is what Kyle just did live using a multiplayer game server. He literally created the image of my dad. Kyle is incredible. So if anybody who's out there, just give Kyle a little round of applause, because the fact that he did this live using a game on a server running in Red Hat OpenShift is crazy. But once again, Kyle made all of this possible. He's doing this completely on his free time. This isn't, something he does in his day-to-day. He helped me with all that. So thank you very much, Kyle, for making this possible. I'm gonna actually pop back into the game, and you'll see me and Kyle are in here. Oops, moving around. So, hey, Kyle, squat for the people. Hey there, Kyle. So thank you, Kyle, for that. I'm going to switch back here. So I'm going to pop back to the webcam just to show my beautiful face. So that today is everything that we're going to cover about creating a multiplayer game server and deploying it on Red Hat OpenShift. Once again, I really encourage you guys to check out the workshop resources, because everything that I've done today, awesome demo and good artwork, Kyle. Kyle is awesome. Definitely check out that the workshop resources, has everything that you need to actually do what we did today with the blocks and everything like that. All the links are in the description. So lastly, I just want to say, check out the files for, if we want to flip back really quickly to the slides. Just things, what's next. I encourage you guys to check out the blog, the article that I shared today on IBM Developer. That will give you all the deep nitty gritty of what we did today, so you can really learn as much as you can. Also, if you're interested, if you're watching now, I really encourage you to check out the Digital Developer Conference happening on December 7th. I will actually be the host. Hey, so you'll see my beautiful face again. I'll probably be wearing this shirt again. This is like my favorite IBM shirt. So you'll probably get to see me in this. But yeah, it's a digital developer conference. It's all about cloud security. We're going to have talks from a lot of different partners with IBM, talking about everything you need to know about cloud security. So if that's something you're interested, or something you just want to hear about, I encourage you to check it out. It'll be a 2-day event, one live event, and an opportunity to participate in webinars in series on December 8th as well. So check out that link within the slides. Also, if you want to keep up with this type of stuff, I actually am creating a even more detailed series about what we covered today on my YouTube channel. You can literally find me on YouTube, Bradston Henry. There's literally only one Bradston Henry out there, and it's me. So I'm the guy. I'm making a YouTube series that I cover the exact same topics, a little bit more detailed, a little bit more. You can also check me out on Dev2. So if you want to learn more additional learning resources, check out the workshop resources. Tons of things about Red Hat OpenShift, about Kubernetes. I really encourage you to check out the Level Up Your Skills, get your Build on Kubernetes badge with Dave Nugent. He did an incredible job. I really see Dave as a mentor to me personally. He's an incredible developer advocate here in North America, somebody to check out. So once again, thank you everybody for tuning in today. I appreciate your time. Thank you for listening in. I just want to thank everybody behind the scenes, Kyle, for Jim, who's been running all of this, sending all the little messages and helping to keep me honest with you guys. So thank you, Liz, thank you, Tracy, thank you, John, thank you everybody who made today possible. Thank you, of course, the North America Developer Advocacy team at IBM. Thank you once again for checking out today's webinar. There will be a replay available soon here on YouTube, Twitter, all over the place. So definitely check it out. Share with your friends. Watch it again. So thank you, everybody. Feel free to follow me on Twitter at BradstonDev. Send me personal messages. I'm always willing to answer questions about anything. I absolutely love helping. So thank you, everybody. Thank you for your time. Everybody have a great day, morning, evening, wherever you are in the world. Until next time, take it easy.